So the purpose of this video is for you to check your work on our first graph interpretation. And I think when we're starting our investigation of climate change, sometimes you hear that called global warming, it really begs that we start here. So is Earth really getting hotter? That's something that maybe you have already been wondering about. And so we're going to analyze 3 graphs to figure that out. Here's the first one. Notice that this graph goes on the x-axis. It shows us the years, time in years, from 1865 to 1995. But the y-axis here is temperature, degrees Fahrenheit. And maybe you've already noticed this is only going up by 0.2 degrees Fahrenheit. So there's only 2 whole degrees in this graph. But to check our work, the first question, the x-axis is years again, the y is temperature in degrees Fahrenheit. Now, what has the temperature done? So I said this, it went up and down a lot. Do you notice that? Another way that you might have typed it is that you see zigzags. So it's not like it's a perfectly straight line. But you maybe have heard a math teacher say you can do a best fit line through there to get an overall trend. And so our overall trend is a definite temperature increase in this period of 130 years. But you might be like, Mrs. Fickus, why did you give us a graph that cut off before we were even born? And honestly, part of that reason is I like that it's in degrees Fahrenheit, and it's hard to find that this is something that we understand what 58.6 degrees Fahrenheit feels like to us as an average global temperature. But what about more recently? So I asked you then to study this graph. So if you look, 1995 would have been about right here, right? So that's when our other graph cut off. And so what you're seeing here is a pretty dramatic increase from 1995 to 2019, which is as close as we could get here to present. And you are looking at this one, notice it is in degrees Celsius. And so this would be honestly just a couple degrees Fahrenheit difference. And so you might be like, well, Mrs. Fickus, is that really significant? And actually, small changes you're about to see, what we would consider small changes in temperature globally can make a big difference for climates on our planet. So let's double check here. Recently, we've seen temperature increase a lot. We're seeing a spike in temperature recently. So our question, is Earth really getting hotter? So far, it's looking like yes. Okay, I have to sneeze. Sorry. Okay, now, the next one, though, puts us in a little bit of a pickle. And what I mean by that is, well, this graph is looking kind of the same. Oh, look, time in years, degrees in Fahrenheit, right? So that's what you would answer for question 4, years and still temperature. But then I asked you to figure out the difference between the coldest and warmest times. So if you look, and here is our now, right? There's actually been warmer periods than now, just a little bit. And I have that little blue dash at about 60 degrees, maybe 60 and a half. Now, if you go down here, where's the coldest period? Kind of close to 54, right? So if you were a little different than me on this answer, maybe just 1 degree different, no big deal, but it's about 6 degrees difference. And so here's my point with this about a little bit makes a huge difference. We now notice interglacial periods. All right. So inter means between. So right now we are not in an ice age. We're in between glaciers. But look, around here, which would be about 30,000 years ago, that was an ice age. Then about 100,000 years ago, an interglacial period similar today. Oh, an ice age. You see how it's going back and forth between interglacial periods and ice ages. And when we say ice age, that's when ice was covering a significant amount of our planet, even down into Ohio. So small changes in temperature make a big difference in our global climate. Now, the question number 5, or excuse me, I misspoke. Question number 6 here is, in general, has it been warmer or colder than now? And in general, you should have said it's been colder for question 6, but there have been slightly warmer times. And then the final question there asks you how many interglacial periods over the last 450,000 years, including today. So that's like those higher temperature points when there were less glaciers on our planet. 1, 2, 3, 4, 5 is the right answer there. Okay, now to finish the critical thinking. So that honestly might be a mistake. Hang on. Sorry about that. Give me a second. Oh, no, that was not a mistake. The question was asking you actually to predict. So, if Earth is left to its own natural cycle, what would we expect 50,000 years from now, right? So, if you could put the graph out here, and the answer to that is that we would expect it to be much colder. So, question 2 you probably already have because you saw a video, but scientists use these things. Do you remember them? Ice cores to determine temperatures a long time ago. That the thick layers of ice means cold temperatures, thin means warm. And then finally, and I think this is the most important question of the day, if we think about the data in all three graphs, is Earth really getting warmer? Is Earth heating up? And I'll tell you that I think I'm option B. Now, notice it says just thinking about the data in the three graphs, right? So what we've seen today, and we're going to expand on this, but I am not surprised if you picked option B. I'm not really sure the data seems to conflict. Our first two graphs say, ooh, in recent times, Earth is getting warmer. But this final graph makes you wonder if this is all just part of a natural cycle. And that's how our unit is going to build.